Dear participants, let's start with second unit of the Programmable Logic Controllers coursework. This unit has got three separate and independent sections. In the first one, we need to know what are the basic concept of registers in PLC. In the second part, we need to know what are the different timer functions that are available with PLC. And the third one will tell us what are the various counter functions that are available with PLCs. Now you see, one important aspect that you need to know is that whenever we talk of these registers, especially registers, then we need to be very sure about the memory map of the PLC. Now, as per the syllabus requirements are concerned, I am not supposed to talk a lot on the memory map. Now, what I will do, I will be supplying you with the memory map of PLC 5 by Alan Bradley. I think that you are already gone through the coursework of microprocessors, in which you have come to know how memory is organized within the processor. So that concept you can similarly apply to understand the basic memory layout in a PLC. Whenever we talk of a memory, then the first thing that comes in that there is a program memory and the other part is a data memory. In the program memory, we actually store the instructions or the program, and in the data memory we store the data on which the instructions have to work or the data which has come out of the instructions. Whenever we talk of a memory, there is a certain part which is called scratchpad area, where the programmer can put something which is free to the programmer. There are some parts of the memory which is not accessible to the user because they are for the machine information and machine personal details of the machine, that how it is going to work, like firmware, that we cannot access. There are some input port, output port, so those section. So memory has got some section which deals with the input port and the output port likewise. Now you see that whenever we talk of a particular PLC, of a particular model, of a particular make, then memory is completely dependent on that particular make or that particular manufacturer. Therefore, while programming a PLC, you should get into the details of the memory map invariably if the program requirement is that such complex. Otherwise, you will put yourself in trouble. Definitely there is no problem if you are using some 10 to 15 lines of program for particular purpose, there is no problem. But if you are handling a large amount of data, and whenever you are using data, that means some analog data has to be stored somewhere. When you are using some mathematical function, then mathematical function has to be carried out over some data. Some data will be generated out of the mathematical function, so you need to store them. So in all such aspects, you need to know the memory map very clearly. This is one thing that I wanted to share with you. The another thing is that timers and counters are inbuilt facilities inside the PLC, and they have made the function of PLC so versatile that you would love to apply them for industrial automation applications. However, the terminologies that are there with the timers, the symbols of the timers that are there in the ladder diagram is different for different models and manufacturers of PLCs. How you are going to program the timer, that I will teach you here. But every detail of the terminologies, how you are actually going to put the data or put the particular constant value of preset time or time base inside that timer, that is completely dependent on practical programming exercises. Because if I want to cover all those things in the lecture, then the timers or counters will take one semester itself. Therefore, I will try to cover as much as it is possible for me. I suggest you that you get into the practical exercises properly. Also, you can definitely get into the YouTube videos about any particular PLC. Suppose you are talking about Siemens S7 1200. So you can get into the programming video of S7 1200 and see that how timers are programmed over there. Because through my lecture you will be gaining the basic of the Siemens PLC timing procedure, how the timers are there in Siemens PLC, how they are basically programmed, what are the basic inputs that are to be given to the timer. Now with this much knowledge it will be very easy for you to grasp the idea, because you see, if there are 8 different manufacturers of PLC, then there can be 80 different types of PLCs. In 80 different types of PLC, there can be at least 50 different type of timer configuration. So unless you get directly into that and involve yourself very much with the programming aspects of each and every version, it will be not possible to know everything. However, I am not just getting you confused. If you understand any one timer properly, then it will not be very hard for you to understand another type of timer within 5 to 10 minutes, because you know the basic of timer. Once you know the basics of timer, then just the format is different in other PLC, it may so happen. You can master it within no point of time. Let me tell you, only your interest should be there. The same is also valid for counter functions. So therefore you need to be serious. Whatever I teach, that is only part of the entire timer or counter fraternity that is available with the PLCs. I advise you to go for further applications, and once you do that, it will be very easy for you to grasp the practical idea of timers and counter application in PLC and how the registers can be implemented in your programs. So with this much introduction, I directly start with the topics. First of all, we need to see what is the concept of registers in PLC. We will come across module addressing concept, the concept of holding registers, then we will go for input and output registers. When these input and output registers are considered to be a single register or they are grouped registers, what are the benefits of that, we will also see. Now see, whenever the term register is used, especially when we are talking of some electronic device, the very first thing that comes in our mind is it is a space where data can be stored. So we can define register as a space where data can be stored. Since a PLC is having microprocessor at its heart, definitely there is memory of the microprocessor, and registers, they are the building blocks of the memory. Just like a brick that makes your house, likewise registers are the building blocks of memories in PLC, rather in any logical device. microprocessors or controllers especially. Now you see, if we consider the PLCs, then each data register can typically store a binary word of usually 8 or 16 bit. Now this particular concept is very important once you try to understand the working of register. You see, register actually, if I consider a single bit, you forget this 1, 2, 3, 4, 5, 6 and 7 bits. This is an 8-bit register. You forget the 7 bits. You consider only 1 bit. If I consider only 1 bit of a register, it can hold either 0 or 1, because we know that microprocessors do not understand any other language than binary language. And in binary language, we have got only two things. Either it is 0 or it is 1. Now you see, whatever 7 blocks that you have forgotten earlier, now you add it. What you can have right now? You are having a particular house in which there are 8 rooms. Room 1, room 2, room 3, room 4, room 5, room 6, room 7 and room 8. 8 अलग-अलग रूम हो जाता है इसमें. And each of this room can hold 1 bit of data. Now this data is either 0 or it is 1. Definitely, because we are dealing with binary number system. Because whatever microprocessor it is there inside a PLC, it works with the binary language only. Now you see here in the given example, this register is containing 8 bit of data. 8 bit of data. So therefore this is an 8-bit register. If here there would have been 16 such blocks, another 8 blocks, then it would have been a 16-bit register. So register is built up of single memory blocks. The number of memory blocks, they decide the width, width, width of the register. In case of PLCs, it is usually an 8-bit register or a 16-bit register. Each and every register has got an address. Each and every register has got an address, and by that address we can determine the contents in that register. क्योंकि अगर हमें उस रजिस्टर के कंटेंट जानना है तो उस रजिस्टर तक पहुंचना पड़ेगा. आप पहुंचेंगे कैसे? If it is a 1 MB of memory, it is a very large memory. So how will you find? So under that circumstances, you should know the address of that register. So another important concept that come into the figure is each register has got an address. Now next immediate question that should trickle our mind is that whether we can play with 1 bit of data of this register or not. It depends. It depends actually. There are some registers in the PLC for which you can manipulate each and every bit of data, and in some cases you cannot play with each and every bit. You have to change the entire 8-bit or entire 16-bit of data as per the specification of the register. Now you see, what is the extent of data that a register can contain? If we are talking of a 4-bit register, then we can store a positive number between 0 to 2 to the power 4 minus 1. Now definitely 4-bit register, the calculation is like that, 2 to the power 4. That means 16. Less 1. Why 1 is less? Because normally we do not consider this 0 as the starting number, but we are starting from 0. So we can hold the data from 0 to 15. Very simple to understand. 0 0 0 0, then 0 0 0 1, 0 0 1 0 till 1 1 1 1. Likewise, an 8-bit register can store a positive number between 0 to 255, and if it is a 16-bit register, then it can store a positive number between 0 to 65,535, because 2 to the power 16 is equal to 65,536. Now you see that your application may require that you need to store negative numbers in the register. Under that circumstances, the most significant bit means the leftmost bit. It is used to represent the sign. How are you going to represent that? You see, if I put 1 in the MSB, that represents a negative number. And if I put a 0 in the MSB, that represents a positive number. And the format used for the negative numbers is 2's complement. आप अगर कोई पॉजिटिव नंबर है उसका नेगेटिव निकालना चाहेंगे तो you need to go for that 2's complement of rest of the bits. So this is basic signed binary. I am not going to talk on that because you have already covered all these topics in your graduation level. But these are the basic concepts. Your register can hold positive data as well as negative data. And you know what is the range right now. Now, if I ask that an 8-bit register is used for storing a positive as well as negative data, or a signed data rather, then how much will it hold? It will hold, you can see this is 0 to 255, this 2 to 55 will be divided by 2. So that much in the plus and that much in the minus. And also you need to consider that one of the bits is there for giving you the sign. So it will no more remain 255. Okay, so these things have to be in your consideration. Now when we are talking of registers in PLC, you see within the PLC CPU, the registers can be classified as either internal register or external register. The internal registers can be 4-bit wide, 8-bit wide, 16-bit wide or 32 bits wide, depending on the microprocessor that is in the heart of the PLC. You see that so far the internal registers are concerned, they are not directly accessible by the user. And this is a typical sentence. That's why I am saying this is a typical sentence, because it may so happen that certain manufacturers will allow some internal registers to be used by the end user. So that depends. But in most of the cases, in general cases, internal registers are not directly accessible by the user. These are the registers which actually assist, or that actually takes care of the control action, the arithmetic functions, the logical functions to happen inside that. So these are the registers that support control function, because if some control function is there, then some data has to be put inside the register, and according to that data some control decision has to be taken. There is some arithmetic function. So in order to do some arithmetic function, what you need to do? You want to add some direct data onto the contents of some register, or you want the data which are already there inside the registers that should be covering some mathematical function. So that is possible. Let me explain a bit more. If you have got 2 registers and you want to add the contents of 2 registers, then contents of those 2 registers will be added, and that the addition, the result will be stored in some different register. or you want that some direct data has to be added with the contents of one of the registers. So all these things have to be done, and in requirement of some process, and for that you require these registers. Now, therefore, you can easily understand that when these registers are containing the data, then that data might come from some process. There is no goodness of allowing those registers directly maneuverable by the end user. However, several PLCs, the software of the PLC rather, they do give you the facility by which you can see what is the content of some register. That you can see, that is possible, that what is the content of this register or that register, that you can see during the programming, when the programming is taking place, when the programming is being executed, one program is being executed, you can see continuously how the values of registers are changing, and at the end of certain program what is the final value of that register, that you can also check. Now you see what are the internal registers: the accumulator register, data register, index register, condition code registers. Condition code means your flag type registers which are there in the microprocessor. Scratch pad registers and instruction registers. Each of these registers, they work to store data temporarily. You can easily understand that all these registers, they store the data temporarily during the course of program execution. When the program is being executed, then many times it is required that some data has to be taken care of temporarily. Likewise, if I just ask you to add two numbers, 76 plus 89. So when you are adding 76 and 89, then what you do actually, 9 plus 6 is equal to 15. You put the 5 and put 1 somewhere in your mind. This is a temporary storage. So such type of temporary storage is required during the complete operation of a program, complete execution of a program. All these registers, they do take care of this. Now you see that whenever we are doing the program, and so far the program is related to basic timer, counter or DIDO, such in-depth knowledge of registers is not required. But if the program goes to a higher complex limit, then we need to be considerate about all these things. Now you see that CPU's RAM contains slots that are designated to variable information. These locations or addresses became the external registers. We were earlier talking of internal register. Now you see the random access memory of the CPU, they contain slots that are designated to variable information, and they are known as external registers. Many PLC modules, as I have already told you, many PLC modules allow visualization or even printing of register contents through specific software facility. I will stop here and I will continue again in the next lecture. Thank you.